want to use an exponent is because say you had a problem that's 7 times 7 times 7 times 7 times 7. You see these have the same number over and over and over in a multiplication problem. To save yourself energy and time and ink, well, you know, another way to write 7 times 7 times 7 times 7 times 7 is the important number that you're multiplying over and over, which is called the base. And however many times you're multiplying that factor to get the product, 1, 2, 3, 4, 5, 7 to the 5th power is another way to write this multiplication problem, and this is called the exponent. This little bitty number on top, up to the right a little bit smaller than a normal number, that will save you time and space, because 7 to the 5th power means 7 times 7 times 7 times 7 times 7. All right, let's see if we really understand that. Here's 3 to the 4th power. What does that really mean? It means this big number here, the base number, times itself over and over and over 4 times. So the big base number times itself, times itself, times itself. 4 threes. Exponent just tells you how many factors of 3 you're going to be multiplying together. 4 to the 3rd power. Well, this looks similar, but it's not. Because this is base number 4 times 4 times 4. 3 of them. 1, 2, 3. Okay? And 3 times 3 times 3 times 3 is different than 4 times 4 times 4. Agree? Good. Don't get your exponents and your base, their jobs mixed up. Because a base is the number you're multiplying over and over. The exponent just tells you how many of those are you going to use. How many of those factors. Cool. Real quick, let's see if you can do 2/3 to the 3rd power. See if you know what that means. Yes, pause. Okay, we're back. Yes, it means 2/3 times 2/3 times 2/3. Your base number can be any form. Write it 3 times 3 of these. That times that times that. Pretty cool? All right, the other thing I want you to know is, just in case you don't know, but the proper language to use when you're talking about exponents is, this little big 4 and little 2, you say 4 squared, okay? 2 makes the 2 directions of a square, boom, boom. Length times width, or side times side, it actually forms the area of a square. So they say squared. It actually, you know, makes the shape of squared. So you say this 4 squared, or 4 to the 2nd power. So you always say the base number first. This one is 2 to the 3rd power, 3D. Because you got length, width, and height. It comes, you know, length, width, and height sticks out at you. So that's 3D. So that's 2 to the 3rd power, or 2 cubed. Because a cube is 3D, it's the 3D form of a square. Cool. The next one, this is a big 5. 5's your base, 5 to the 4th power. 10, 10's your base. What is this one? Did you pause ahead and write it in yourself? Good job. This is, 10 to the 5th power. 10 to the 5th power. Yeah, do you remember that when we did our powers and exponents? They call them powers. Exponents are tiny, but they're mighty because they're very powerful. They make the 10, this is a 10 with, 5 zeros. I mean, it makes it big really fast. Cool. What are they going to ask you to do with your new knowledge? They're going to ask you to evaluate. Evaluate. What is the value of 4 to the 2nd power, or 4 squared? Well, that's just 4 times 4, or 16. There's your value. What's 3 to the 4th power? 3 times 3 times 3. Thank you for checking me. Times another 3. Big base, 4 times. 1, 2, 3, 4 threes. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3, 81. The value of 3 to the 4th power is 81. Let's evaluate 10 to the 5th power. Do I have to write out 10 times 10 times 10 times 10 times 10? No, because we've already discussed that this is a 1 with 1, 2, 3, 4, 5 zeros. A 1 with 5 zeros is what this little guy means. How many zeros are you going to have? That's the fun, cool trick about powers of 10. 10 to the 5th power is a 1 with 5 zeros, which is 100,000. Cool. All right, product of primes using exponents. You knew this day was coming. Let's see what it looks like. Let's find the product of primes. Let's break this down to its prime factors only. And we're going to use our build a cake method. And I'm going to say 2 into 1800 goes 900. And another prime number I can divide by is another 2, because this is still even, 450. And this time, I don't really want to divide that by 2 because it's not sticking out in my head. I'm going to choose 5. Yeah, 5 goes into 45, 9. And 5 goes into 0, 0 evenly. So I'm going to go 5 times 90 is 45. And another 5 goes in once, 18 times. And another 2 and a 9 and a 3 and a 3. Cool. Look how many prime factors 1800 has. 1, 2, 3, 4, 5, 6, 7 prime factors. All right? So another way to, we can write 2 times 2. Don't forget to stay in numerical order. Times 2. Boom, boom, boom. Times 3 times 3. Boom, boom. Times 5 times 5. Shoo, that made me tired. I wonder when I know that could help me. Exponents. Yes. So 1800 can be written as a product of primes like this, or like this. Big base, 1, 2, 3 of them, times big base, 3, 2 of them, times big base, 5. Yeah, 2 of them. All right, this way. Anyways, you guys are going to have to, practice this, okay? All right, I hope you get